All right, hello, ladies and gentlemen. In this video, we're going to go through the calculations. How do you figure out how much acid and how much water? Because we need to know these two numbers so you can figure out these two numbers. But since none of these numbers are going to be the same for every person, I'm not actually going to plug any numbers in. I'm just going to tell you how to figure out those calculations. Now, we're starting with our acid calculation. That's why it's written first, because you have to do it first. This is a dilution. So we need to use the dilution equation. So we're starting with M1V1 equals M2V2. We need to figure out what are we looking for. So looking up at this question, which is itty bitty on this worksheet or on this Google, on this video, it's kind of itty bitty. So you're going to have to pull it up on your worksheet. So pause this and do that now because you're not going to be able to see the stuff I'm pointing out. So first thing we have here is determine the volume. So that has to be a volume of 6 molar HCl. That's a molarity. You are going to need to make a 100 milliliter. To make 100 milliliter, that has to be a V of a blank molar solution. That is a molarity. And this number is the number from your card. The card I gave you is the number that goes in that blank. So now we need to figure out which ones are ones, which ones are twos. Well, make means to. It means post. It means after. It means final. This is what I want to end with. So these have to be twos. So I'm making V2 and M2. If these are twos, that means these are ones. So what we want to find is V1. So our equation here is going to be V1 is equal to M2V2 divided by M1, or is equal to M2, which is your card, times V2, which is 100 milliliters, divided by M1, which we are going to assume is approximately 6.00 molar. I will tell you the actual concentration of the solution you're using once I make it, because I haven't yet. So yeah, do that calculation, and that gives you V1, or the volume of acid that you need. This number, once you get it, is this number, and that's where it goes on your data sheet. Once you have this number, you can also put it here under chemicals and come over here to your acid Erlenmeyer, not Erlenmeyer, your acid grad cell, and make a note of how big of a graduated cylinder you need. This should be more than this. Now, that said, if this is 35, you don't have to use a 100 mil grad cell. You could use a 25 mil grad cell and do it twice. Get 25 once, or approximately 25 once, and then the balance, or whatever is left, the second time. And then you could use a 25 mil here and get more precise data than if you just use the 50. Or we don't have 50s. Just use the 100 from this. So keep that in mind as well. And the same goes in reverse. If this only needs to be 35 milliliters, you don't necessarily have to use a 100 mil grad cell. Now, that's our acid. Now we need to figure out our water. So for the water, we're looking for delta V. That's it. It wants delta V. How much water do I need to add to make this solution? Well, this is what we're ultimately wanting to end with. We know that our delta V equation is V2 equals V1 plus delta V. We want delta V, so V2 minus V1 equals delta V. So take 100 minus whatever this number is, and that's your delta V. Okay, and then that number goes in this blank, the volume of DI water you're going to need. It also goes in this blank. And then once you have that, you can figure out what this size needs to be. And that's pretty much it. The one last thing I want to mention is this blank right here, molarity target. That is the number from your card, and it should be in this data table on your experimental data. When you turn in your lab notebook, your introduction, these 3 numbers should be filled in already. So make sure that they are before you turn it in. I'm going to wrap this here. This video went a little quicker than the first one did. Thank God. So I'm going to wrap it, and we'll have a good one. See y'all next time.